Hello friends, welcome to this YouTube channel. Today we are going to solve a couple of numerical problems on resistance. By solving these problems, we shall observe how change in length or cross-sectional area of a conductor affects its resistance. When temperature remains unchanged, the resistance of a conductor is directly proportional to its length, that is, R is proportional to L. It is inversely proportional to its area of cross-section, that is, R is inversely proportional to A. It depends on the nature of material. Now we can write R is proportional to L by A. Therefore, R equals to rho into L by A, where proportionality constant rho is the resistivity of the material or specific resistance. When L equals to 1 meter and A equals to 1 square meter, R equals to rho. Hence, specific resistance or resistivity of a material is the resistance offered by 1 meter length of wire having an area of cross-section of 1 square meter. A copper wire is stretched so that its length is increased by 0.2%. We have to determine the percentage change in its resistance. First case, let the length of wire be L1 and cross-sectional area be A1. Volume of copper Vol1 equals to A1 into L1. Resistance of the wire R1 equals to rho into L1 by A1. Second case, let the length of wire be L2 and cross-sectional area be A2. Volume of copper Vol2 equals to A2 into L2. Resistance of the wire R2 equals to rho into L2 by A2. According to the problem statement, where length is increased by 0.2%, therefore L2 equals to 1.002 times L1. Since Vol1 equals to Vol2, A1 into L1 equals to A2 into L2. Therefore, A2 equals to A1 into L1 by L2. That is equal to A1 divided by 1.002. Resistance of the wire R2 equals to rho into 1.002 times L1 divided by A1 by 1.002. That gives us 1.002 square times R1. Change in resistance R2 minus R1 divided by R1 equals to 1.002 square times R1 minus R1 divided by R1. That gives us 0.004 per unit or 0.4%. A piece of 10 cubic centimeter of copper having specific resistance of 1.7 micro ohm centimeter is drawn into a wire of 200 meter length. We have to calculate the resistance of the wire. If this piece of copper is rolled into a square plate of 10 centimeter side, we have to compute the resistance between the opposite faces of the plate. Let us first write down the given data. Specific resistance of copper rho equals to 1.7 micro ohm centimeter, that is equal to 1.7 into 10 to the power minus 8 ohm meter. Volume of copper, vol equals to 10 centimeter cube, that is equal to 10 into 10 to the power minus 6 meter cube. First case, when the piece of copper is drawn into a wire, length of wire L1 equals to 200 meters. Since volume of copper vol equals to A1 into L1, cross-sectional area A1 equals to vol divided by L1. Using values we get 10 into 10 to the power minus 6 divided by 200. That gives us 5 into 10 to the power minus 8 meters square. Let us now calculate resistance of the wire. R1 equals to rho into L1 by A1. Using values we get 1.7 into 10 to the power minus 8 into 200 divided by 5 into 10 to the power minus 8. That gives us 68 ohm. Second case, when the piece of copper is rolled into a square plate, given side of the plate L2 equals to 10 centimeters. Let us now calculate cross-sectional area. A2 equals to L2 into L2, that is equal to 10 into 10, that gives us 100 centimeters square or 0.01 meters square. In this case, volume of copper vol equals to A2 into T. Therefore, thickness of the plate T equals to vol divided by A2. Using values we get 10 into 10 to the power minus 6 divided by 0.01. That gives us 10 into 10 to the power minus 4 meter or 1 millimeter. Let us now compute resistance between the opposite faces of the plate. R2 equals to rho into T by A2. Using values we get 1.7 into 10 to the power minus 8 into 10 into 10 to the power minus 4 divided by 0.01. That gives us 1.7 into 10 to the power minus 9 ohm or 0.0017 micro ohm. A copper wire has a resistance of 5 ohm. The wire is drawn so that its length increases 3 times. We have to calculate the resistance of the new wire. Let the resistivity of material be rho. First case, resistance of the wire R1 equals to 5 ohm. Let the length of copper wire be L1 and cross-sectional area be A1. Volume of copper vol1 equals to A1 into L1. Expression for resistance of the wire R1 equals to rho into L1 by A1. Second case, let the length of copper wire be L2 and cross-sectional area be A2. Volume of copper vol2 equals to A2 into L2. Expression for resistance of the wire R2 equals to rho into L2 by A2. According to the problem statement, length increases 3 times. Therefore, L2 equals to 3 times L1. Since vol1 equals to vol2, A1 into L1 equals to A2 into L2. Therefore, cross-sectional area A2 equals to L1 by L2 into A1. that is equal to 1/3 A1. Now, resistance of the wire R2 equals to rho into 3 times L1 divided by 1/3 A1. That gives us 9 times R1. That is equal to 9 into 5. That gives us 45 ohm. A copper wire of 1 centimeter diameter had a resistance of 0.25 ohm. It was drawn under pressure so that its diameter was reduced to 50%. We have to determine the new resistance of the wire. Let us first write down the given data. First case, diameter of wire cross section D1 equals to 1 centimeter, that is equal to 1 into 10 to the power minus 2 meter. Resistance R1 equals to 0.25 ohm. Cross-sectional area A1 equals to 5 times D1 square divided by 4. Let the length of the wire be L1. Volume of copper Vol1 equals to A1 into L1. Expression for resistance of the wire R1 equals to rho into L1 by A1. Second case, diameter of wire cross section D2 equals to 50% of D1, that is equal to 0.5 times D1. Cross sectional area A2 equals to 5 times D2 square divided by 4, that is equal to 5 times D1 square by 16 or 1/4 A1. Let the length of the wire be L2. Volume of copper Vol2 equals to A2 into L2. Resistance of the wire R2 equals to rho into L2 by A2. Since Vol1 equals to Vol2, A1 into L1 equals to A2 into L2. Therefore, L2 equals to A1 by A2 into L1, that is equal to 4 times L1. Resistance of the wire R2 equals to rho into 4 times L1 divided by 1/4 A1, that is equal to 16 times R1. That is equal to 16 into 0.25, that gives us 4 ohm. We have to calculate the resistance of a 100 meter length of wire having a cross-sectional area of 0.04 square millimeter and a resistivity of 50 micro ohm centimeter. If the wire is drawn out to 4 times its original length, we have to calculate its new resistance. Let us first write down the given data. First case, length of the wire L1 equals to 100 meters. Cross-sectional area A1 equals to 0.04 square millimeter, that is equal to 0.04 into 10 to the power minus 6 square meter. Resistivity of the material rho equals to 50 micro ohm centimeter, that is equal to 50 into 10 to the power minus 8 ohm meter. Expression for resistance of the wire R1 equals to rho into L1 by A1. Using values we get 50 into 10 to the power minus 8 into 100 divided by 0.04 into 10 to the power minus 6. That gives us 1250 ohm. volume of the wire, vol1 equals to A1 into L1. Second case, length of the wire L2 equals to 4 times L1. Let the cross-sectional area be A2. Volume of the wire vol2 equals to A2 into L2. Resistance of the wire R2 equals to rho into L2 by A2. Since vol1 equals to vol2, A1 into L1 equals to A2 into L2. Therefore, A2 equals to L1 by L2 into A1, that is equal to 1/4 A1. Resistance of the wire R2 equals to rho into 4 times L1 divided by 1/4 A1, that is equal to 16 times R1. Since we have obtained R1 equals to 1250 ohm, R2 equals to 16 into 1250, that gives us 20,000 ohm. Two wires having equal length and made of the same material have resistances of 25 ohm and 81 ohm respectively. We have to calculate the ratio of their diameters. If the length of the first wire is 50 centimeters and resistivity of the material is 1.72 micro ohm centimeter, we have to determine the diameter of each wire. Let us first write down the given data. Resistivity of the material rho equals to 1.72 micro ohm centimeter, that is equal to 1.72 into 10 to the power minus 8 ohm meter. For first wire, given resistance of the wire R1 equals to 25 ohm, length of the wire L1 equals to 50 centimeters, that is equal to 0.5 meter. Expression for resistance of the wire R1 equals to rho into L1 by A1. Therefore, cross-sectional area A1 equals to rho into L1 by R1. Using values we get 1.72 into 10 to the power minus 8 into 0.5 by 25. That gives us 0.0344 into 10 to the power minus 8 square meter. For second wire, given resistance of the wire R2 equals to 81 ohm, length of the wire L2 equals to L1, that is equal to 0.5 meter. Expression for resistance of the wire R2 equals to rho into L2 by A2. Therefore, cross-sectional area A2 equals to rho into L2 by R2. Using values we get 1.72 into 10 to the power minus 8 into 0.5 by 81. That gives us 0.010617 into 10 to the power minus 8 square meter. For the first wire, we have obtained cross-sectional area A1 equals to 0.0344 into 10 to the power minus 8 square meter. Let the diameter of wire cross-section be D1. Expression for cross-sectional area A1 equals to pi times D1 square by 4. Therefore, diameter of wire cross-section D1 equals to root over 4 times A1 by pi, that is equal to root over 4 into 0.0344 into 10 to the power minus 8 divided by pi. That gives us 0.02093 into 10 to the power minus 3 meter or 0.02093 millimeter. For the second where we have obtained cross-sectional area A2 equals to 0.010617 into 10 to the power minus 8 square meter. Let the diameter of where cross-section be D2. Expression for cross-sectional area A2 equals to pi times D2 square by 4. Therefore, diameter of where cross-section D2 equals to root over 4 times A2 by pi, that is equal to root over 4 into 0.010617 into 10 to the power minus 8 divided by pi. That gives us 0.01163 into 10 to the power minus 3 meter or 0.01163 millimeter. Let us now determine ratio of diameters. D1 is to D2 equals to 0.02093 is to 0.01163. That gives us 1.8 is to 1. So today we have solved a couple of numerical problems on resistance. By solving these problems, we have observed how change in length or cross-sectional area of a conductor affects its resistance. Hope this lecture has been useful for you. If you have any suggestion or question, please drop it in the comment section below. If you have liked this video, give it a thumbs up and share it with your friends. Thank you.